Okay, so now we're going to do a video how we do our detention on the site. We use a program called HydroCAD Stormwater. Okay, there's several out there. Autodesk comes with one in Civil 3D called HydroFlow software. I've never learned to use it. It's not too difficult. It just does. What I like about this program here is we use the rational method for almost all of our projects for detention because the size of our sites are so small and it works quickest and easiest. Most of the municipalities accept that without any problem. So we use that. Now, what I like about this one, if you remember, as you do a rational method, the most important part for figuring out your hydrograph is the critical duration of the storm. And this is the only program that I know that will actually calculate that critical duration without you having to back into it by guessing and doing. That's the way I have always done it. That's why I've liked this program and using this program for years. I'll go way back to DOS based with this program because I could work the critical duration out. Like it, that's the way I do it. So what I'm going to do is, like I always do, is I rob Peter to pay Paul. I've always told y'all that. I tend to grab the last good one that I use for a project and save as. So I'm gonna go to the last one that I did for this client and his, and I'm gonna click on it and do. Okay, I had a whole bunch of. I'm not gonna use that one because that one had a bunch of stuff in it. That one was a little more difficult, a little more complicated. So let me go back to this one. I could have kept the last one, but I wanted to do it in the same state. Sometimes it's just a little easier. Okay, and this is probably going to be my scenario. I'm going to have two ponds, so I'm going to have a couple of drainage areas that I work with. We'll walk through that as we go. The very first thing that I have to do is I need an IDF curve for this site. I don't have one for this particular site, and so I need to find one. So this is the way I do it. You can go right here in the hydrograph calculations, go to rainfall, IDF curve, says more IDF. Hit download, it'll take you to their website. And I know I should have it bookmarked, okay, but I don't. So I go here for details, NOAA, and there's the website, okay? And you can slow the video back if you got to pick it up. All the states in blue where they have data. So basically what they're going to do, I'm going to click on here, and I'm looking for a rainfall station where they picked one for this site. They have rainfall stations that the National Oceanographic Association, they have rainfall stations all over the U.S. So I'm looking for one as close to my project as I can get it. So the first thing I'm going to do is I'm going to go down here. I'm in Rolling Fork, and I have one in Rolling Fork. So I'm just going to use the one. You can't get much, get close, zoom in. You can't get much closer than that. You can't roll in, zoom in. You have to use plus minus on this site. But I mean, that's as close as I'm going to get to the real rainfall for that particular site. So what I do is I'm click it, the hand clicks on it, and I highlight, I click it. It sets that site. You see it did something right here and pull the name in. Gives me all this data right here. I don't really care what it says because I know what it means. I want the default here. I'm just going to hit submit, and it pops up a box and asks me, hey, where I want to download this CSV file. Well, I want it to go into Program Files, X386, HydroCAD, IDF files. But I don't want it to be a CSV. I want it to be all files. I'm going to click on anything right there. And I learned something. If I tell it MS dash, it'll organize these by Mississippi. I just found this out, something neat. So now I can start organizing by state. Type in Rolling Fork. And basically it's a comma delineated file. So it can be you can save it as a text file, you can save it as a CSV file, whatever. But HydroCAD wants it in the HCI format, but it just takes this file and imports it all in. It's in the right format for it. So I just need to label it and call it that. Hit OK. I'm done. I'm going to hit close. And it says, oh, do you want to use that one? Well, shoot, yeah, I want to use that one. Okay. So what event do I want? I'm in Mississippi working for the DOT. Rolling Fork doesn't have any requirements. So what I'm going to do is just I'm going to do a 25-year storm for the DOT, because that's who I'm worried about discharging eventually onto. So I'm going to hit OK. And then I'm going to go to settings, calculation, rainfall, make sure it kept it, and it says yes. All right, so now what I need to do, I'm going to minimize this a second. Now I'm going to go back to my existing conditions drawing, okay, which is my existing survey, because I need to do a handful of calculations, okay. I need to determine what my project, I need 3 items for this. I need the total acreage, okay, or total project size. I need it in acres, and I need it in square feet, because my data will be input that way. Then I need my existing impervious area and my existing pervious area, okay. All right, and so what I'm going to do is, normally I just write that down. I actually have an iPad that I keep a lot of data on, and I put it in there, but for this convenience, I'm just going to open Excel, pop it in here, and start a new file, and I'm just going to call it Rolling Fork MS Stormwater, and I'm going to total site, acres, square feet, impervious, pervious area, pervious area. Okay, that's the first piece of data that I got to have. So what I'm going to do is I'm just going to use AutoCAD, and I'm going to draw some polylines and stuff around this stuff. So I'm going to draw a polyline around the site. I don't care what the surveyor said or whatever. I'm going to draw my own polyline. I'm going to double check any numbers that may have come in, just so I have. And I can list that polyline, and it'll give me the area, and I can just copy it, pop that into Excel, tell it that, and say that equals that number divided by 43,560. And what I should have done is I should just call this, let me do something, let me clean this up a little bit, insert a line, because I'm just making it as I go. Total site, square feet, acres, right? Okay. And so that number right there never needs to be more than 2 decimal places. So number, 2 decimal places, that's plenty. And that one really doesn't matter either way in that. Okay, so I'm going to look at my impervious area, and that's impervious is what doesn't shed water. So I'm going to go through my concrete here. I'm just going to go from endpoint, just going to draw a polyline around it, get the area. Now you can do this 100 different ways. I've done it this way all my life. I've done what's on my site, not off-site here, unless it's a lot of off-site, and I'm basically going to replace that drive with my drive. So nobody's called us out and said, oh, well, you got all this and you didn't do that. So I do what's inside my property line, unless it's very obvious that I got a lot of off-site coming from somewhere I've got to worry with. I don't have to on this one. So I'm just going to draw some polylines through here and here, that point, and now make sure you get all your existing, because that helps you in your calculations. This is an existing slab that's being demolished right there. and that's going away, or some of that's going, but that's existing to there. Okay, and I can do like this. Look, it don't have to be perfect. You just want a couple of square feet and you're close enough for everything we're doing in stormwater. They're not going to bing you for being a square foot or two off. Because in the old days we just used to just scale it or use one of the kilometers or something like that. So we're a lot more accurate than we used to be. Okay, a whole lot more accurate. Okay, so that gets that, and that's really all my impervious area. So my impervious area is how much? It's this much right here. So we'll copy that number, put it into here, and so pervious must, it's not right, 829 is not right. What did I do? Got the wrong number. I didn't get to 20 for it, did I? That would have been nice for my cows. That would have looked really much better. But and this number is going to be that number. Whoops. That number minus that number right there. Whoops. Minus that number. And then I'm going to go over here and just area check. I know, but equals that number plus that number. Make sure I didn't screw my formula up. I want to make sure those numbers match. Okay? I just double check myself a lot. And that's what you should be doing. If you're not double checking yourself, then you need to I'm not going to say you need to check yourself in what you're doing, but you need, if you're not double checking yourself, you risk making mistakes. And when it gets out in the field and these kind of things, it costs you a lot of money. Okay? Alright, now I'm a pervious and impervious area. The only other thing is I need my time of concentration. Okay? And I'm going to close this and open it back up because I thought I had my surface in here. I may not have. I don't think, I probably did not. I don't have my surface in my survey. I don't bring it in here. Okay, I couldn't remember. Had to get my mind in the right place. All right, so close this. All right, so time of concentration is the farthest point that water has to travel to get to discharge at the site. So we can do this with our water drop. We click right here, click us a path, just cause water drop. We can start right here and see that water goes that way, just to kind of see where our water goes, existing water on this site goes. So really what's happening is it's probably coming right here to right there. This right here would probably be the travel path for my time of concentration. Okay? And so I'm going to do a couple of things. I'm going to use my tools here. That's why I have them. Do some slope on this. And let's see. 2 point. That's pretty flat right there. That's 2.8%. That's 0.25. That's 0.36. 0.99. Okay. So I'm just trying to figure out how I'm going to figure out my time of concentration. You know, the flatter it is, the longer it takes for that drop to get somewhere. So we want to come off there. That water's probably going to run just like that right there. Even though that tried to go in that direction, you pretty much can say that that's going to go like that. Okay, that's probably a good number right there. I'm going to back it here so it'll be a little flatter because it gets steep here at the end. Okay, I'm going to draw me a polyline right there and get a length. So the length of that is 142. So what I'm going to do is time of concentration calculation. I'm going to say length, and I'm going to use 150 feet. And slope, I'm going to use 0.57. Okay. 0.57. Okay. I just need that information for HydroCAD so we can calculate that existing conditions. All right. So let's see here. I'm gonna try something new. See if I can get these two suckers side by side right here on the same screen. I have two screens and I use them all the time, so this side by side stuff. I think there's a way that I reckon I need to learn how in Windows you can make those things side by side. So anyway, so excuse me. So let's do my existing site. I'm gonna call this existing site. And now what I'm going to do is I'm going to calculate the pre-development flow rate for the entire site, and then I'm going to have two ponds, and the sum of those flows off of the site have to be equal to or less than the existing conditions, because they're all eventually coming to this point. See the invert are 95, 85, 96, 64. There's the invert of that pipe, and 95, 99. So it's really, this is all flowing in that direction. Okay. Even though that says 95, 89, I'm guessing everything's going to the highway. Okay. It's definitely not going back here. This is definitely coming out here. So it's either coming here and going that way or going in that direction. Okay. So we're just going to get it in this ditch system over here. All right. So we're going to pull these programs back up. So call existing site the area. We told the area, the impervious area was 2829.70, and it rounds off even that. And the pervious area is 42667.31. Okay. Now I usually use 0.4 for my coefficient for existing conditions. This site, I could probably make it a little bit higher because this site's developed. It's a little harder in doing, but I think I'm going to be okay with what I'm doing with ponds and stuff, that I'm going to need so little for pre and post difference that it's not going to matter in that. Time of concentration. Okay, so I'm going to delete this row. I'm going to click on it. I'm going to go with sheet flow method, because sheet flow is basically calculated over the first 300 feet for time of concentration. After about 300 feet, it should start channeling up. Well, the length of our, if you remember, the length was only 150 feet, so we're probably not going to get any channel flow. It's all going to just sheet flow. So for what we're doing, that's what we'll use. The surface, I'm going to give it short grass. If you look at it, it's probably closer to almost a smooth surface, but short. Surface description is short. It gives it a Manning's End flow length of 150 feet. And then we did the slope of 0.0057. It's in feet, so that's there. Click. So it gives me a 15-minute time of concentration. Okay. Now we can do two things. We can go in here, rainfall calculations, time span. Rainfall, and we can set that duration right there at 15 minutes, and it'll fix our intensity. Or we can just click on this and click duration and hit update, and in about 20 seconds or so it'll calculate the duration of that storm and set it to what we want. It's 15 minutes at 5.02. So what I'm going to do is I'm going to say T sub C is equal to 15 minutes, and Q pre is equal to 5.02 CFS. And yeah, you can just come in here and let's see. Got this thing small. I can't find nothing here. There we go. I can't ever remember where to. I'm just gonna make it lowercase. I can't remember where a subscript is. I'll have to Google it. So we just do Q3 like that. Okay. So now I know what I'm working for. Okay. So there's my existing site. Now we're going to go back here, and we're going to select similar and erase those, and select similar and erase those. Okay, and erase that. So we don't have anything else in this site that we don't want to mess up. Okay. Now I'm going to go back to my design drawing. okay? Because now I've got to determine what is my post-condition flow rates. Well, the first thing I got to do is divide the site into two pieces. Because I got a front and a back, and basically the only thing that goes to the back is that inlet, where I put that inlet in, and then the building. Everything else is going to the front, okay? So what we'll do is we'll let this thing load up, and it's going weird. That flashing over there, it didn't like my surface. Okay, something weird on my existing surface. So you gotta be careful here, because something's weird on my existing surface, because it's doing a bunch of calculating every time I touch that surface. Okay, so what I'm gonna do is, let's see if I've got some layers created here. No, because this one doesn't have any. So I'm gonna create a layer for the drainage. Their existing, proposed drainage areas. I don't really care what color. I think one's fine. Whoops, one's fine. Right here, and then we'll set it current. Hit OK. So what I know is, let's look over back here to our proposed drawing. So we basically drew a line from right there straight across, from that corner of that sidewalk straight across there. All that's going in there, and that's going to the back. So we're going to kick right here, and we're going to draw a line, polyline from the corner of the building to here, perpendicular to here. And I'm just going to include the rest of this part of the site in it. Whoops. To there, and there, and there, and there. And I'm going to split the difference right here. So what I'm going to do is I'm just going to see if it'll pick me an apparent intersection of that. It's right there. Do right here. Okay. So I'm just drawing it around my building, because what that's going to do is that's going to give me a drainage area that goes. Alright, so now that says everything from there, from here forward goes to the back, and this goes to the front. Now I need my pervious area, because what I know is I'll list this areas. So we'll go back to our spreadsheet here, and we're going to insert a line here. Call this pre-developed conditions. And then we're going to call this post-developed conditions DA-01. Okay. Total site area, impervious area, pervious area. Okay. Now, for the proposed, because everything's going to be hard surfaced and it's a small area and it's moving fast, time of concentration for the proposed for this site, for me, I always use 5 minutes. You can't get less than 5 minutes. That's hardly ever greater than 5 minutes, because it's going off so fast and the site's so small. So I just use that. So that's all the data that I need to put in here. So I'm going to get DA1 and DA2. So I have them. Whoops. There you go. Now, so we'll look at the total site here. It is 37,147. Okay, so it's here. So we know that. Whoops, that's right here. Sorry about that. What we know is that if that's like that, then that should be that number minus that number. Okay, so it should be 26,349. Okay, because that's what's left over there. So now I just need the impervious area on both sites, and I can finish the calculations. So what's nice about using spreadsheets, you can cut your calcs down. You don't have to think about them. You just let the computer do the work. Okay, you just have to know what it's doing so you don't screw up. So I'm doing a polyline from here to here. That's all lines. If you hit A for arc, it goes right to an arc, and L for line. Back to arc. Alright. Back to an arc. Then line, arc, line. Same thing here. We just go to here because that driveways are about the same. I just normally don't do that off the site. That's just the way I do them. Nobody said anything. Hopefully somebody that reviews my plans is not looking at this. Now, if you never used a polyline to work on an arc that's not tangent, you can hit A for arc, okay, and see it tries to create an arc at a tangent or whatever. If you hit S for second point, you can pick a point on that arc and the end point of it, and it'll draw it right on top of it, which is a really neat tool that I found a long time ago. Alright, and then I'm going to come back here and create this. Finish drawing that. Okay. So give me just a minute here. We'll get this drawn in. Close that. Alright, so now I know what the impervious area for that is. And this is area 2, right? Because it's right, so that's area 2. So this must equal that number minus that number. Okay. So I can erase that line because I don't ever need it anymore. And now I'm going to go here, impervious in the backside. You know, I know everybody's like, why can't you just push a button to make all that happen? That's what my developers and contractors think. You just push a button. You do it all on computer. It just pushes a button. No, you still got to act like you're doing stuff by hand, because Civil 3D, Autodesk products here are not SmartBIM related. They were similar to Revit. Maybe we could do that if we built everything like we would in a Revit model, and everything was three-dimensional and everything. We might could do that, but we can't do that here. So we have to do some manual stuff like we're drafting, but still better than rolling that kilometer around or taking a bunch of areas and squaring them off and adding a bunch of numbers together. We can just draw a polyline around the objects and find out what it is right there. So we know that one, we know that one is 19.5, and this is going to be what we call drainage area 1, impervious. So pervious is equal to that number minus that number. Okay? And if we want to do an area check, we can. Right there. Right there. Notice I've copied them in the exact same format, so for Excel that was great, so it checked them. Okay, so I just need that data to put into here. Okay, so I have drainage area 1, we'll have drainage area 1, and we'll have drainage area 2. We won't have this other post over here. Okay, so now we're going to come in here, and this is 01, and we know the area of the impervious is 19.592.08, and we know the impervious is 17.5.48, and we're good. Okay, I use the same 0.9 and 0.4 for asphalt. Those are numbers that are standard for stormwater design for coefficients in the rational method. You can go look those up if you need to check those. Time of concentration, this is a direct entry method. We just tell them it's five minutes. Okay, now I can go back in here and set that 5 minutes right here. I can do that. It gets the intensity set, so I can look at that and find the flow. And if you want to double check that we did the duration right, we'll just double check it just so you can see that 5 minutes that it does work. What you need to know is with HydroCAD, and it's probably that way most all of these programs. Once it determines that duration for something that shouldn't change, like these pre and post conditions, the duration should never change. Your pond will change based on modifications you make to your pond. If you make the pond bigger or smaller, the inlet outlet smaller or bigger, that duration would change. This duration will not change, but it won't hold it. So when you go to do your final calcs, you'll need to go back and recalculate that. So it did come back in. So 5.79 is our CFS. And so what we should have done is added a line right here and say Q post, and that's 5.79 CFS. Okay, and we'll copy that and put it right down here and edit area is 15759.32 and 1059.0.13. T sub C is 5. Hit OK. Hit OK. Check our duration. Rainfall 5 minutes. Rolling Fork 10, 25-year storm. We're good. Whoops. Hit the pond. The pond blew up because the pond wasn't ready for it. All right. So 4.36 on that one. 4.36. So individually, one of those works, one of those doesn't, but combined, that's 10, a little over 10 CFS. So we got to have some ponds in there, which we knew that. Okay, we knew that. So now I don't need this line. I'm gonna make this line some width to it, so I can see it, and so we do that. All right, so I'll come back in here and clean my side up, clean all this up when I finish my plans later. Just gonna save that for the time being, so I don't lose it. I'm gonna go back over here. It's gonna tell me to reload it because it's got that new line in there. And give it a chance to reload. I'm telling you that there's something about that surface that they have, even though it's just a simple surface, that it's reading those triangles and it's killing my file. You see my screen flashing. That's all has to do with the surface. But somebody sent that to me, surveyor did. I'm not going to modify that surface because I don't want to screw something up and now I have a bad surface and something's messed up with my side. So I'm just going to freeze that line I put in there. Okay, because I don't care for anything else. All right, now so I'm ready to put my pond in. So I'm going to put one in the back, and I'm going to just discharge it right here. Okay, so I really kind of want a long, skinny pond, but it's got to be. If the top of that's 102.82, it doesn't need a lot of pipe out of here. 12-inch pipe is plenty big to get that water out of there. And how do I know that? Because I've been doing this for a long time, and I know 12-inch pipe, if I calculate it, was more than enough for that little area of water. Okay, so I need to be able to come from right here, somewhere along in here, and put a pipe that, if I put 2 foot of cover, and if I do 102.805, so I'll go over here, if I do 102.805, and I'm minus 2 foot, if I put 2 foot, this equals 2 foot of cover and a foot of pipe, then I've got 3, and that equals that number minus that number. I need to be at 99.8 at least for the bottom of my pond, because that gives me 2 foot of cover and a foot of pipe. Okay, if I didn't quite want 2 foot, if I could get by with a little less than 2 foot of cover, then I could probably set the bottom of the pond at 99. But I mean at 100. That's 3 foot deep. I'm probably going to do that. I'm going to, because that's only 2/10. It's only a couple of inches. Most of my developers are okay. They don't have a little less than 2 foot of cover. We're okay with that piece of pipe coming from here to here. And it'll get deeper anyway quickly as it goes. So It'll have plenty of cover by the time it gets some heavy truck and stuff on it. So I'm going to set the bottom of my pond at 100 based off of that. Okay, because that puts me 3 foot deep. I don't want to be I don't want to be any deeper than 3 foot, because if I get any deeper than 3 foot, then I got to have a fence around it. Okay, so I'm going to offset that 5 feet, and if you remember, that was, oops, go back to lines. The bottom of that is at 103.21. So if I come off 5 foot, I sloped a couple %. So that's pretty good. 3 to 1 gives me 2. That's 103, 102, 101, 100. That gives me a 3 foot deep pond. I don't want to be deeper than that. 1, 2, 3 foot deep. Okay. Make it 5 foot wide on the bottom. 100, 101, 102, 103. And it's coming here somewhere about right here. And come down to, whoops, 2, 1, 0. Okay. And now I'm going to change my UCS. I've talked about how to do this in a previous video. I'm going to copy this line right here. Oh, I don't know, about 100 feet. Okay, and I'm going to set that 3, 1, 1, 0. Okay, fillet radius of 2 for the inside of that, because every pond is going to have some kind of radius at the bottom. And now I'm going to offset that like that, so that I don't have to put all those fillets in and stuff. Okay. Okay. Alright, so that puts it in. Then I'm going to need put some pipe in there. I'm trying to stay away from that pole right there. 99, 100. Okay. So I'm going to have about 70 foot piece of pipe. Ugh. But I don't want to be bigger. I've already made that pond way bigger than it ever needs to be. Okay. So, alright, it's way bigger, because we're going to go in here. We're going to start entering our pond. So we're going to go into this. Alright, so we're going to click a pond, edit the pond, and it's a pond, use detention pond here, storage. Alright, we're going to click on here. We're a custom stage storage, because what it'll do is it takes the area in the perimeter, and it does some calculations, and it gives a pretty accurate volume based off of the area and the perimeter calculations. You can read about it if you want to understand how they calculate it, and how they come up with the volumes based off of that. But I just call it irregular shape, and it's got a calculation it does. So it's going to be at 100.0, and what I'm going to do is I'm going to click here, and I'm going to list that. Whoops, list that bottom one, and pop this back up, and we'll hit space, and I'm going to copy that, and I'm going to remember that 188.57. Copy that 188.57. Okay, it's still over there. Okay, doing these a little different than I normally do. I have 2 screens, and it usually works a little better. Then I'm going to click on that one, and it's going to pop up, and it's going to be 1045.54 and 207.42. I'm just looking for the area and the perimeter of those two. Okay, and then we're going to get the third one. Whoops, get the third one, and it's 102, and it's 1696.06, and it's 226.27. And then we'll get 103, and it is, pop that back up, it is 2403.13, 245.12. Okay, so now we put a pond in, not a big deal. Now we're going to go to our outlets. We're going to delete this. Okay, And we're going to do a pipe. This is the cheapest thing to do here, so we'll just do a custom, an orifice grate, culvert, excuse me, there it is, culvert. Invert elevation of 100. It worked out, it just happened to work out on this one. It's not normal. If we do 99 and the length is 70 feet, 70 feet, it'll calculate the slope at 1.4%, okay? Manny's in, we'll look it up. We're going to use HDPE pipe, so PV smooth interior. We're going to start with 12-inch pipe. Well, what we want to do is we want to work our pond where it works. Outlet's oversized, it may put out way too many CFS, and then we want to back into how small we can make this outlet without topping the pond out, pipe out, okay? So then we have to have, it wants the, I usually monitor conform to fill for the entrance KE for filling the KE, so my KE is 0.7. It's what I always use. Okay, so we put a pipe in. We're not going to do tailwater on this one because hopefully we won't have to. Some DOTs make us do it, some don't. This one's probably never going to have much water in it, so it doesn't really matter. Okay, so now we can click on it, and it gives us our CFS. It gives us, shows us no warnings or anything. Everything looked good. The only thing we don't know is that's set for our T sub C of 5 minutes. Okay, but that's not the true hydrograph for this. Why we got to calculate the duration. So if we go over here to the duration and hit update, just let it do its thing, it'll calculate the correct duration for this pond with that outlet on it, and it's going to shift a little bit. It won't be 5 minutes, it'll be 8 or 10 possibly, because this is really a big pond for this area, but I have to be because I have to get that pipe out of there, and I don't know any other way to do it. I hate to do it. It's 9 minutes, 3.14. So if you remember right, we're trying to get down to 5.02. What I'd like to do, we're only at 101.3. So what I'd like to do is let's just make this an 8-inch pipe because it's cheaper. Okay. And check our duration again. Notice it came down way a bunch. The pond's going to get bigger. Get fuller, which is fine because it'll just flow right out of this pond pretty quick. In fact, it'll tell you, I'll show you in just a second, it'll tell you when the pond will be empty based off of free flow and discharge. Okay, so see the time of concentration went up. The duration went up to 24 minutes because it's holding more. See, it's almost a foot higher in here. And then this will show you the hydrograph. It'll show you when that pond, how much storage it's got, and notice that in about 4.5 or 5 hours it's empty. Okay, so it doesn't hold water long, even at that. So I'm gonna use that number. Okay, so that duration was 24 minutes. And that CFS is 1.89. So I'm going to come over here. I need some information from that because it's going to go into my stormwater report or my information on my drawing. And what I want is, I want the duration. It's 24 minutes. I want the Q. The Q host is 1.89 CFS. I need the peak elevation. Okay, 101.96. That's data that I need. That's the data that I'll need to finish my report right there. Okay, is all I need. So, okay, so that's pond 1, easy to see and do, and we'll grade that in a minute. Okay, we don't need that line anymore. Now we want to put a pond out here. We have the same thing. we're going to start right here at the end of this flume, because we know we want to be at 101 for the top of our pond. If you remember me talking about that a while ago, because of the way we did our flume, it worked out perfect. So we're just going to put it in here somewhere. Okay, we're going to make sure these elevations right here, we'll make sure all three of these elevations at this point, properties are elevation 0, because of what we're doing. Okay, and we're just going to, we don't know what we're going to do. We're going to copy this one down to 75 and offset here at 3. Okay, so that puts me, that'd be 101, so I'm right at grade right there, and I can just dump out. I'm probably going to do this one, I'm going to do this one a little bit different for sure. So we'll put a little radius around here. Okay. I'll set that 3 foot like we did before. Erase those right there. Okay. Now we're going to go in here and make sure, see if we can make this work like we made the last one work. We already got all our data in, so we're going to go into our pond. Did we fix our area? Make sure we did all our area right. 26,349. Yep, we already put our area in. Okay. Just have to double check myself. Doing little things here. So edit, pond. So we'll start at 100. And let's look at this. And we're at 1792, 27, 188.85, 101. And it will be, list that one. And it will be 2387.10 and 207.70, and we don't have anything else. Hit OK. Now this outlet, what we're going to do here, because this is 101 right here. This is actually that ditch, kind of going back, trying to drain back that way. So what we're going to do is we'll regrade this just a little bit right here, and we'll put us a flume, just a concrete flume out here. We'll show a detail. That detail will say it can be concrete or grass, and they'll just put a little flume in here. And I bet we can make this work with the flume. That's the cheapest thing we can do. So we're going to do a sharp crested rectangular weir, invert elevation of 100. We're going to start at 2 foot. Why? Because I want to make it work. Once we make it work, then we'll see how far we have to pick it back. Now, if you remember, our last post was 1.89, and if we look over here, our existing was 5.02. So if we say 5.02, and this equals this number, and this equals that number minus that number, we need to have our number at 3.13. Okay, well, we're there. Okay, so I really don't need that big a pond, so I'm going to move it in a little bit. I say 10 feet. Okay, now I'm going to list this again, and I'm going to change my pond size, edit, storage to 1072.27, 168.85. There's no science to this because I really don't know what it needs to be. I'm just guessing. Okay, I'm just trying to make it a little smaller so I don't have to move as much dirt. I got too much in the bag. Okay, alright, let's see what that is. 2.15, what did I say I could be at? 3. 1 still look good, so we have to check the duration of this again. Okay, so we'll run them through the duration and let it do its thing, and if these two numbers are less than 5.02, then we're good. So we'll wait till this does so we can check our sum. So this one is 7 minutes and it's 2.92, so we should be good. So what we're going to do is we're going to come in here and say this is, what did I say that was, 7 minutes? Yep, 7 minutes. 7 minutes. 2.92. Peak elevation at 100.61. Okay. Now Q pre is equal to that. Q post is equal to that number plus that number, and that's less than that, so we're done. Okay. I'll create my report and all my information for my data for later. Actually, with the Mississippi DOT, I don't have to do a report normally. I can just put this data that I created. That's why I have all this information here. I can take this data and put it straight to my drawing, and the information is on my drawing. And most of the time, if it's in a rural area like this, they don't check me and ask me for a stormwater report, so I don't have to do anything. So that's all I need to do in this report and for this video. So I'm gonna stop this video in this one and go back and finalize the grading for this site.